Hi, you're listening to the Stephan Livera podcast focused on Bitcoin and Austrian economics. Today, with episode 105, we're carrying on with the hardware wallet series. But first, let me introduce the sponsors of the podcast. Firstly, Kraken. Over my years in Bitcoin, I've been really impressed with the way Kraken operate, both for their incredible focus on security and also for consistently acting ethically in the space under Jesse Powell's leadership. They're one of the longest standing Bitcoin exchanges. They're consistently rated the best. They offer some of the best liquidity available in the industry, and if you're a trader, you know that's what you need. They've got high trading volume, low fees. Kraken also offer 24/7 support, and on the institutional and business solution side, they're providing best-in-class accounting, reconciliation, reporting services for cryptocurrency hedge funds, asset managers, and fund administrators. Kraken also have an OTC desk for those higher touch, large block trades. Kraken offer 5 fiat currencies and also offer margin and futures trading. So to learn more and sign up, go to the Kraken link in the show notes. Next up, Unchained Capital. If you're looking for a product that allows you to easily set up a 2 of 3 keys multi-signature vault, these are the guys to look for. They can use Trezor or Ledger wallets. It's in a web wallet. It doesn't require a great deal of technical skill to set it up, but remember, you still maintain control with your 2 keys, helping you distribute that risk, and you can keep the keys stored in different locations. And so on the other side of that is you can also choose to enter into a Bitcoin collateralized loan, meaning you can get USD liquidity without selling your Bitcoins, meaning you don't trigger a capital gains event. So that might be more tax efficient for you. And while that loan is outstanding, that Bitcoin is then stored in a dedicated multi-signature address under what's called collaborative custody with Unchained. So Unchained would hold one of the keys, you would hold a second key, and Unchained's independent third-party key agent would hold the third key. So to learn more and sign up, go to the Unchained Capital link in the show notes. Alright, so we are carrying on with the hardware wallet series. So basically this is the final episode. My guests are actually both repeat guests. They are Justin Moon. He appeared on SLP36. He's a developer and Bitcoin educator. He's the guy running BUIDL Bootcamp, Mooniversity, and also the upcoming BUIDL Bootcamp. Stepan Snigirev, he is the CTO of Crypto Advance. He appeared on SLP84 when we were talking about quantum computing, and we were also talking about his work with Crypto Advance, working on new hardware wallets. These guys are both working on some really interesting stuff in terms of DIY hardware wallets and multi-signature, so I had to get them on to talk about it. So here is the interview. Stepan and Justin, welcome back to the show.
Thanks.
Hey, how's it going?
Yeah, so look, I've obviously had both you guys on the show in the past, so I think we don't need to do the intro stuff, but I hear you guys have a really cool story of how you two met. Do you want to go into that? Justin, do you want to start?
Yeah, let me do that. So I got into Bitcoin a little over a year ago, and I dove in really hard, and I took Jimmy Song's class, and then I was like, oh man, that was great. I want to go to a conference now. So I went to a conference in Lisbon called Breaking Bitcoin, and I did the hackathon there. And so it's like, early in the morning, getting ready for the hackathon. And there's all these people sitting around, and we're all programmers, so we're all introverted, sort of sitting, minding ourselves. And I just started walking around and meeting people, like, what are you going to work on? And people were making a website or it's kind of boring things. And then I walk up to this Russian guy, and he's got this big box of wonderful gadgets in front of them. And I asked him, what are you going to build? And he's like, I'm going to build the first Lightning hardware wallet. And so I'm like, oh, I'm working with you. And that's how we met. So we ended up actually building a Lightning hardware wallet. It's more like a Lightning button. Stefan, do you want to describe he was the real mastermind of it. So do you want to describe what we made?
Yeah, so also from my side, Breaking Bitcoin was also my first Bitcoin conference. So I seriously started thinking about moving into Bitcoin like 2 years ago or so, and I spent like half a year writing my own Bitcoin library and going to Jimmy class and so on. This conference was I was entering this completely different world at that moment. So I had to be prepared. So I decided, what can I do? What will I enjoy doing during this hackathon? And I put all my toys into the box, like NFC chips, GPS chips, and all the other stuff that I had. And I was just thinking, okay, on my way there, I will figure out what exactly I want to build, but I definitely want to build some crazy Bitcoin hardware. probably a couple of days before the conference, there was an announcement from the C Lightning team that they have very interesting and modular structure, such that they have a completely separate daemon that is responsible for signing. And I thought, okay, what if we just replace this daemon with the hardware? Then we will have a Lightning hardware wallet. And it will be definitely something fun to do. And even if we will fail miserably, at least we will enjoy the time there. Yeah, so I was sitting there and kind of gathering people around me, and we ended up with the largest team in the hackathon, actually. It was really crazy 2 days, I think. It was 2 days in a row, like 14 people or so working on that. It was a lot of fun. But eventually at the end, it was not even close to what we wanted, but it behaved very similarly to what it should do. So eventually we got the first prize, even though we cheated a bit with the functionality of the thing.
No, but that sounds great. I think it was one of those things that then spurred on a lot of other ideas and collaboration.
One of the other interesting things there is that a bunch of the people from the team ended up going and working at hardware wallet companies, Shift Crypto in particular, the makers of Bitbox. And I've been, teaching people about to make hardware wallets in my class. Stepan now has a company, so I don't know. It was it was one of those really interesting experiences where a bunch of people, some people come together, and a lot happens in 2 days. And
we still are connected.
Yeah, exactly. And I think part of it is that that this topic, like Bitcoin hardware wallets, is just so interesting. Like hobbyist Bitcoin hardware wallets trying to take off-the-shelf pieces and put the puzzle together is really, really interesting. And you learn a ton about how Bitcoin works and how security works. And just different considerations.
And how hardware
how hardware works, how computers work, because you're just dealing with this little simple machine, and so that's sort of the genesis of why we wanted to jump on the show, is like to share a little bit of that enthusiasm and hopefully get a bit of a community together, like we have with hardware nodes, right? We have the Raspberry Bolt, Raspberry Blitz, a lot of these open node projects. Which is great. I think it would be cool if we could have sort of at the same time some open hardware projects where you just get off-the-shelf pieces and construct them into a usable hardware wallet. So that's kind of the thesis here. That's what we're trying to kind of communicate.
Yeah, and by the way, it doesn't have to be only hardware wallets. It can be any kind of hardware. So, for example, Ben, BTC Socialist, is working a lot on this point-of-sale terminals for Lightning with these small things. And also there were projects like candy machines and electric scooters and things. So just would be nice to put all this together and kind of get more and more people experimenting with hardware and Bitcoin.
Yeah, right. And I think, as you mentioned, the Lightning hardware at Bitcoin 2019, I think that was the one with OpenNode. We're doing the hookup for that, and Ben, I think, helped with that. And then people could just pay with one sat and then play the little arcade game. So that was a pretty cool demonstration of real world Lightning. Here you go, and it was on these little pieces of hardware that Ben was making. So that was pretty cool. So look, I guess for the listeners who are thinking, oh, hang on, how do I rolling my own hardware wallet? Why would I look into this? Like, isn't it just much cheaper and easier to buy one off the shelf?
So doesn't have to be cheaper. Like, it can be cheaper actually. So, for example, one of the projects that Ben is working with us at the moment is like $5 hardware wallet. So none of the shelf hardware wallets can cost $5. I don't know. Even OpenDime is probably more expensive. And also another thing is that do-it-yourself hardware wallet will never be as secure as the off-the-shelf hardware wallets from Trezor, Ledger, and others, because obviously it's do-it-yourself, and you are probably not better than a huge security team of a large company. But if you add it into your multi-signature setup, the multi-signature is additive. So every new unit increases the security. It doesn't make the security worse. So even if you add a do-it-yourself thing, you actually improve it by introducing a completely different security model into the system. So it is like very weird setup with off-the-shelf components that are not a target of the supply chain attacks, for example. And even if someone will see this hardware wallet, they will probably not guess that it is a hardware wallet. It will be just a weird-looking box. Yeah. So some security, you can get some security from it.
And you can also get some pretty good air gaps. Like one of the big problem with current wallets is that almost everything uses the micro USB wire, and that's sort of complicated, and a lot of attacks are possible there. And so now we have like some cold card uses micro SD card, which is better, but it's quite feasible to make a QR based. Like Stepan and I have both made QR code based air gapped like hardware wallets. And as far as I know, you can't really buy one of those right now. And so you can get some better features, like air gapping wise, that you can't buy yet, which is, I think, really interesting.
Yeah, right. And on that topic of QR code, let's talk a little bit about that, because as I understand from speaking with some of the hardware wallet manufacturers, one of the concerns shared was that it's difficult to transmit enough information inside a QR code because the difficulty is about how much you can encode into one QR. What are your views on that?
Well, basically, we can use QR codes in two directions. First one is we show the QR code with, let's say, unsigned transaction on the screen of the computer. And then it can be pretty large, actually, because the computer screen is pretty large. And in principle, you can put a few kilobytes into the QR code. So it's normally when we were experimenting with this, a standard transaction of a couple inputs and couple outputs fits in a single QR code. It's fine. If you are dealing with a larger transactions, or if you are using a crazy multi-signature setup where there are 20 cosigners, for example, then you may need to split it into 2 or 3 QR codes. But still, it's like not 20, it's just a few, and in most cases it's just one. And if you're using a cheapish camera that cannot really scan this kind of QR code, then yeah, the usability is pretty bad. But there are pretty cheap industrial QR code scanners, so like very similar to what you use in the mall, what you see in the malls, and they can scan very large QR codes of a few kilobytes at least, so they can easily scan the QR code with the PSBT. And on the other side, when you're sending back signatures, you can really get rid of all other data but the signatures. So you basically need to display only a few signatures, and then the QR code is pretty small. And it depends on the screen, but I think that a few inch screen can handle QR code like this. And the phone camera can scan it. So, Justin, you worked with a smaller screen, right? So I'm using the screen that is 4 inches. And
yeah,
yours is
I've been working on this little project called BitBoy. By the time the episode drops, I'll have tweeted out a bunch of stuff about it. But so it's a little hardware wallet made on an M5 stack, which is a really cute little like $40 computer with a nice screen, a case, and 3 buttons. And there's some nice attachments you can get. So this attachment I'm using is like a QWERTY keyboard. So it's BitBoy because it kind of looks like a Game Boy. And it also has a QR code scanner bolted onto it in sort of a Frankenstein manner. So this screen is 320 pixels by like 240, I think. So it's like about 1.5 inches across. And on this screen, I'm able to display a QR code of a single signature. So when I when I finish signing, it just displays one QR code for every input that was signed. And this is sufficient. You have to sort of have a nice webcam to scan it because it's kind of small, but it does actually work. And this is like very with a bigger screen, it would obviously get a lot better. And most transactions that everyone uses is just one or just a couple signatures. So I don't think it's too bad. The one tricky thing is that you do need sort of a more powerful microcontroller to drive the screen to be able to display the QR code quickly. Mine kind of takes a little while. It's probably because the implementation isn't perfect, but you want the QR code to show up quickly.
Yeah, because you're also using MicroPython that is a little bit slower. Yeah. Our do-it-yourself hardware wallet uses the screen that is 4 something inches. So exactly the same as was used in first iPhones. And there, actually, the QR code with several inputs can fit perfectly because it is like 480 by 800 pixels resolution. So large QR codes can fit there. And scanning again is very efficient and easy because if you use an industrial QR code scanner chip. So it is a little bit more expensive than the cheapest camera. So like if you get a cheap camera, it is a few bucks, and these QR code scanners, can cost about 40. So probably this is also a reason why we don't really see QR code hardware wallets, because it is somehow expensive. This scanners works really well. And another nice thing is that they have a separate chip that processes the images, and therefore you don't put all this code of image recognition into your main code that is storing the secrets. So like you have a physical separation between the parsing of the images and the user data and the main microcontroller that is controlling security critical peripherals like display and the private keys.
Great. And so I guess while we're on this topic, let's talk a little bit around what parts would be needed for let's say the user wants to roll your own hardware wallet. So we mentioned here the QR reader, we mentioned the M5 or something similar. What other parts are needed? How difficult are they to get?
So for our hardware wallet, we are using a developer board from STMicroelectronics. So it's just a single developer board that you can buy from any electronic store like Mouse or DigiKey or anything else. And it already includes this screen and the microcontroller. And then on top of that, you only need to add the QR code scanner and maybe an adapter such that you can just plug them together without any soldering. So ideally, in principle, you can just buy 3 parts. When they arrive, you just unpack them and put them together like a Lego style. And then you just connect it to the computer to upload the firmware there. And in case of these boards, the firmware upload works as simple as just drag and drop of the file into the USB drive. Yeah. With the M5 stack, it is a little bit different. So there, Justin, maybe you can say what you need for BitBoy.
Yeah, so BitBoy is more like there's sort of a difference between. I want to make a distinction between some of the stuff Stepan is working on. It's more like a little. It's like a real Bitcoin hardware wallet. Mine's sort of like for the lulz, sort of. I teach it in my class, BUIDL Bootcamp, and so it's not really like it has a Wi-Fi chip, so it's not really the ideal thing to use. But it's the M5 stack platform is really nice because they have all these amazing peripherals and stuff. So the actual the main piece is like $40. And by the way, you can go to DIYBitcoinHardware.com. That's a little website we've set up for this to see all the little instruction lists, demos, everything we're going to talk about. And also like a history of hardware wallets. We were just looking a little earlier on GitHub at the first ever hardware wallet. It was created like 7-8 years ago. It's like, wow, it's gotten a lot easier since then. So we're going to have that stuff up on DIYBitcoinHardware.com. I'm sure it'll be in the show notes. So the M5 stack's like $40. The peripheral is like another 30, and then the QR code scanner is like 25. So for about the price of a cold card, it's a little less than a cold card. But of course, it has a Wi-Fi chip, so this is not ideal for like real use. But it's like a really fun thing to learn with. And my emphasis for my project is more like making the code really easy to understand. It's all Python, so like any programmer could kind of jump in and learn quite a bit. Whereas Stepan's is like a real thing that he's building a company around.
One call out, and you guys mentioned this earlier, is that this potentially does dramatically reduce your risk against a supply chain attack, because theoretically it's like general purpose computing device. It's not as likely that somebody is going to try and insert some vulnerability or exploit before it arrives at your door, right?
Yeah, mostly because, if you are, I don't know, a guy who is delivering DHL packages and you see a bag that is labeled as Trezor and Ledger, you know that probably this device will be used to store Bitcoins. So you have a large incentive and you have a very high probability of a successful supply chain attack in this scenario. If you're delivering some random maker's stuff, you don't know if it will be a hardware wallet or maybe it will be just a meteor station that will show the weather outside of the window. So like the probability that this hardware will be used for Bitcoin is way lower. Yeah. So this way, supply chain attack is much less probable.
One really cool thing about this hobbyist hardware wallet idea is that it would be feasible with some degree of a little bit of technical sophistication, but not that much. And maybe, in the next 6 months, not right now, it's still a little bit of a work in progress, but you could get to a point where somebody could like set up a multi-sig wallet with like a couple different, building blocks that hopefully we'll be able to create. And nobody in the world would know this person owns Bitcoin, which is amazing. They just buy it off the shelf and download the software over Tor, stuff like that, and they wouldn't leak the fact that they have any interest in Bitcoin to like really anybody. And that's sort of tough if you have to buy hardware or a hardware wallet from a manufacturer, or if maybe you could get someone else to buy it for you. But I think it's just like a cool sort of push the edge cypherpunk idea that you could do this and nobody would even know that you're even interested in the whole topic. And on a kind of related note is like, if you ever got into a situation where, Bitcoin became a huge target, like say there was a very horrible terrorist attack or something, and Bitcoin became a political target, and, the hardware wallet companies were a target as well. Like I think an ecosystem like this it's sort of like the Blockstream satellite, right? Hopefully we never need that, but it'd be great if we sort of have some of these devices in the background. So like in case something goes really wrong and we can't depend on hardware wallet companies, not for their own fault, but for some, just for political reasons or something, it'd be really, really good if we had the ability to construct hardware wallets as people could go and construct one using just off the shelf stuff. So it's not exactly supply chain, but it is kind of supply chain, because the risk of supply chain isn't just that it gets hacked and you lose your funds. It's like, what if the whole thing goes down? There is a chance that something like that would happen, just like there's a chance that Bitcoin network activity would get censored, at which point the satellite becomes really useful.
Right, yeah. So I would summarize that then as helping build resilience in Bitcoin's hardware network, let's say, if you will. And so while that's said, I think the listener at this point, they might be thinking, well, hang on, most of the typical hardware wallets, they've got a secure element. Would this DIY wallet I make, would that just be more easily hackable? Is the idea that I would use multi-signature and have tamper-evident stickers so I know if it's been tampered with? What's the consideration there?
Okay, so there are a few secure elements that you can buy and use off the shelf. Like the one that Codecard is using, and also others from Microchip. Otherwise, in principle, the security of your do-it-yourself thing will be lower. But for example, in our hardware wallet, the do-it-yourself version that we are releasing soon, we just don't store the private key ever. So you just every time you boot the device, you need to enter your recovery phrase, and then even if someone will get your hardware wallet, they can't really extract your private key because it's never there. So it is used only when you use it. You enter it, you sign the transaction, and then it deletes the private key. So like every time you can even use something like a disposable hardware wallet. So like you buy off-the-shelf component, you program it, you use it for a single signature, and then you crash it with a hammer or burn it into the microwave or something. And then you know that every time you have a clean hardware, and like no one will ever get your private key.
Yeah, let me jump in right there. That sort of gets to this like broader question of like, what is a hardware wallet anyways? Like when I first encountered a hardware wallet, I'm like, okay, this is the thing I hodl, right? I get this and I just protect it, right? But that's really not, I think that's how a lot of people approach them. But that's really not the way you should probably or usually use them, because hardware wallet firmware can get out of date. The device can fail. Like that's not a very like physically not a very resilient piece of device, right? You really want your private key in some sort of either many copies of it or in some sort of more resilient, like in crypto steel or something, just so it can a fire doesn't take you out. Just like hodling one hardware wallet is not a great way to do it. And so like one of these sort of hobbyist things we're working on right now, that's how BitBoy works right now, is like, yeah, it's really great if it's more like a UI for your seed, right? It's like the minimal environment, the minimal computing environment to turn your seed into an address and a signature. Like that's really what you want. You want to be able to turn your seed, your private key, into addresses and signatures while exposing it as little as possible to the environment around it. And so that's kind of like the question. Other hardware wallets sort of generate the seed. They use they look for some source of randomness on the device and generate the seed. And I don't think hobbyist hardware wallets will probably be the best at that. But I think one thing they will be really good at, given that they have like big screens and nice keyboards, is facilitating like sort of like provable generation of mnemonics and seeds from dice rolls, just like Coldcard does. And I think that's maybe, if you just get some good casino dice, I think that's a really good way to get your randomness. You don't have to trust in all this magic and computing, all the stuff that could go wrong in computers. You can just sort of throw it out and just roll your dice and enter them in. And so, there you can get generation and interaction with your seed. It's just not very good at storing it long term. But hey, you could you just maybe just store the seed in steel form and just introduce the hardware wallet when you want to interact with it 5 years later.
Also, a side note. So first of all, ideally, you want to add several sources of entropy. So you can add your dice rolls, plus you add environmental noise, for example, from the antenna or analog input, and you also can add the true random number generator that is built in most of the chips nowadays, and then you add all of them together. And whenever you add random stuff to anything, it becomes actually random. So even if one of them is random enough, then you are safe. And another nice thing about this hobbyist approach is that you can also make your own custom tamper-proof features. For example, you can program your hardware wallet such that if someone is moving it and then the hardware wallet wakes up and asks for the PIN or whatever, and if the guy doesn't enter the PIN in 10 seconds, then it erases all the secrets, for example. Or maybe something else, like, I don't know, laser lights and cage and really sci-fi anti-temper measures, like someone crossing the laser and again, all the secrets are get erased. So with this approach, you can experiment and go crazy, actually.
Great. And with the skill required to assemble these devices, you mentioned earlier that it's kind of like Lego style assembly, no soldering required, and also the powering of it as well. Is it presumably that you would do something like the Coldcard, where you get a power bank and you plug it with a micro USB to charge or to power these devices?
So M5 Stack, as far as I know, has a built-in battery that lasts not for long, like for half an hour or so, but basically there you have a battery that you can charge if you want. For our thing, you don't have a battery like built in, but you can just buy a battery like 2000 milliamp hours or so and plug it in. So depends on your skills. So if you want to stay like really Lego style without any soldering, then it might be a little bit tricky adding an external battery. But if you're okay with soldering, then a couple hours of work and then you have a full phone form factor hardware wallet that has both a QR code scanner, the battery, and the charger. That like the USB port that is only used for charging. It doesn't even have any data lines. So something like this. M5 Stack is even easier. It is really built, like already has a casing and really easy to plug in.
I think in terms of the skills required, it's still like it's still a lot of like, this is for tinkerers, and if you don't want to tinker, like stay away for like another 6 months. Like, but if you like tinkering, which I think a lot of people in Bitcoin do, and a lot of a lot of people's interest drives them deeper. If that's sort of you and you want to tinker around, then it is fun, and you'll have to do some like maybe some command line stuff at some point. Maybe you'll edit a little Python code or something. So it does take, like right now it is a little more hands-on, but I think we're like, hopefully we can get to the point where it's basically as simple as updating your firmware on your Trezor or something. You just plug a couple things together, plug it in, run a command, and click a button and get your firmware update. Hopefully it can get to that point over the next 6 months. That's sort of like the goal. So we're kind of here sharing our progress a little prematurely, but hopefully, like, and part of the reason is we'd like to get some more people to both test out and contribute to these devices, because we've had like a blast playing around with them in the last year. So yeah, it's still kind of difficult now if you're not a tinkerer, but I think in 6 months it could get a lot easier.
Great. And well, you mentioned earlier there just the firmware as well. So what sort of firmware will these devices have? What language would they be written in? And then what's the idea to keep them updated? So, Bash32 addresses, Schnorr, Taproot, all of that.
So I'm currently focusing more on C and C++ and Mbed framework. So Arduino, Mbed, and C style. So it is a little bit low-level language. But we are slowly moving towards MicroPython and Embedded Rust. Yeah, we are working with Justin on the MicroPython Bitcoin library. So I wrote all the low-level C code that is basically providing some efficient primitives for elliptic curve math and hashing. And he wrote all the Python part for hardware wallet. So it is way easier to program in MicroPython, I would say. But unfortunately, at the moment, sometimes you need to go deeper to the C level. So sometimes you always find some problems that you cannot solve with MicroPython, and you need to go a little bit deeper. So in that sense, it's really great that we work together with Justin, because we can kind of collaborate on both sides and really make a big progress. So the last thing that we did, like 1 month ago, right? We started this MicroPython port. Yeah, and you wrote really like everything. So from the all the functionality that I had in C and C++, you wrote within this 1 month. That's crazy.
Yeah, so I think part of the goal here is like it takes a lot of plumbing to get something that works at all. Like you're just like plumbing and it's boring, and you're like really low level trying to get C code to work and like underneath. But once that all works and you can sort of access the C cryptography or like display driver code, all the low level stuff that's got to be fast, and you can start to just write normal Python code, which is like the most accessible programming language, and just pull in all this stuff that me and Stepan spent like a year building, or like in various forms. Like we've been kind of working on it for a long time. And so like that's the idea, is I think building on top of this is going to get really easy now that we've sort of put a lot of this stuff underneath all these sort of libraries. And then another thing that
Yeah, so like to prepare a toolbox that people can use, that a bunch of useful libraries like for QR code display, for addresses encoding and other things.
Yeah, so that's sort of the idea is like long term. I think it would be really good to have a couple of these firmwares in different languages because sometimes languages have you can have a bug in one implementation and not in the other. So in like a multi-sig, it's really nice if you can have stuff written in different languages. And so like C++ is one, MicroPython is another, embedded Rust is a third. And the idea is these would just be like very simple, like all they do is sign Bitcoin transactions, deal with seeds and HD wallets, a couple things like that. And so very minimal, like no shitcoins, which is weighs down a lot of other hardware wallets. An emphasis on auditability. Like if you want to figure out like, well, how exactly does one of these big time hardware wallets like verify change addresses? It's actually quite difficult, even if you're a programmer. Like there's so much code in these that they've sort of produced. So the idea is these things would be very auditable. So it's not as hopefully less code. And another thing is like it'd be great if we could have some different computing platforms. Like currently mine is this ESP32. It's more of like an Internet of Things platform, so not really ideal for hardware wallets. Stepan is using STM32, and there's this like RISC-V or RISC-V. I never know how to say it. It's a little more kind of like an open source computing platform. And actually, Vladimir Vanderland, the lead Bitcoin Core maintainer, is on their like Rust steering community. So he's like, there's a lot of interest in this computing platform. So like, it'd be cool to have a port on every language that targets sort of a different platform, and you could just sort of pick these three together in a multi-sig, and it'd be really like a diverse setup. You'd have like 3 different languages, 3 different platforms. That would be pretty interesting, I think.
Yeah, that's fantastic. And let's now talk about the software aspect of it. So, how would this hook up to the blockchain? How would I hook it into Electrum, or how would that work?
Well, let me take this one. I've been working on this a lot lately. So yeah, I've been largely trying to figure out how to do multi-sig in my personal life. Like I want to graduate to multi-sig like a good Bitcoin adult, and still having trouble with that, to be honest. Electrum works, but it's not the easiest, and I always have trouble with my node and my Electrum personal server like crashes. I'm not very good at like that sort of thing. So yeah, I've been trying to look into how to write a UI for multisig using Bitcoin Core directly as a watch-only wallet. And so the idea there is like, Bitcoin has all this wallet code, and usually you interact with it through the Bitcoin Qt, the GUI that they made, right? But the Bitcoin Qt, while it's very secure and excellent and like audited by all of the Bitcoin Core developers, it's written in C++ and it's sort of a very legacy code base, so it evolves slowly, and features generally show up there last. So you pay and use for you pay for the security with some usability, but you can also access the Bitcoin Core wallet on the command line. And in Andrew Chow's episode, he was telling about how he still uses it on the command line. And a lot of Bitcoin Core developers, I'm sure, use it on the command line. But another way you can do it is something called RPC. RPC means remote procedure call. Like usually a procedure call means you're like exercising a function in a programming language. Like a sum function would take 1, 2, 3 and then return 6. So remote procedure call is like the same idea, but the person who the source of the information might be on a different machine, for example. That would be your hardware node, right? So like you'd have a hardware node in your network that's running Bitcoin Core, and you can do this RPC thing to do commands and then get a response back. So that's what, if you heard of RPC, that's what it means, remote procedure call. It's like a procedure, but it's remote somewhere else. And so the idea is this is another way you can access Bitcoin Core. And so like if we can, so I made this project called Junction, which uses RPC to create a watch-only wallet for a multi-sig. And so the way it works is you set it up, it creates one of these watch-only wallets. Watch-only means it doesn't have private keys. So Bitcoin Core on your internet-connected machine has no private keys. So if it gets hacked, it's not a problem because it has no private keys. The worst you can leak is your privacy. So you create this watch-only wallet, and then we use this HWI project created by Andrew Chow, described in the previous episode with him, And there's a command that allows you to get the XPubs, the public keys, on each one of your hardware devices. And so you plug in each hardware wallet, you extract a public key, which is needed to construct a multisig script. And then once you have that, you're able to use something called the descriptor language, which Andrew Chow also mentioned, which allows you to export a huge range of addresses from my little junction thing into Bitcoin Core's wallet. So that means it'll watch these addresses for incoming funds. And this is really powerful because you're able to export huge amounts of addresses very quickly, very easily. And lastly, you do this wallet create funded PSBT. Andrew also talked about this. You provide the outputs you want, the address and the amount, and Bitcoin Core actually chooses the input. So Bitcoin Core is a sophisticated coin selection algorithm, which it uses here. And then you once again use HWI to sign this PSBT, partially signed Bitcoin transaction, and broadcast it to the network. So it's really cool. It's like this minimal UI that allows you to interact with hardware wallets and use Bitcoin Core full node for all the blockchain stuff. So, and the best thing about this is like it's a couple hundred lines of Python code. It really speaks to all the work that's been done by the Bitcoin Core developers with the descriptor language, with these PSBT, with HWI. So I think this really we're really close to being able to have hardware wallets UIs that plug in directly with Bitcoin Core. Just because a few years of work into making this easy is sort of like culminating now. So that's the idea, is we could have a UI like this, and we just add a QR code scanner for these hobbyist hardware wallets. And then all of a sudden, boom, since we all use a standard PSBT format, now we're able to pass around this thing over the serial port for a Trezor, and then it goes over a QR code to Stepan Specter, his project, and it goes over a QR code to my little BitBoy. So that's the idea, we're moving towards that. But I think a lot of it's just because the Bitcoin Core developers have made all these improvements to the RPC layer of the wallet, which allow sort of application developers like me to come in and expose that to the user.
Got it. And so, as from my own fooling around with Bitcoin Core, I see when you go into your Bitcoin folder and you open you do nano bitcoin.conf.
Oh, there you go.
Open up the conf file. Right, and then there's an option you can set there, like RPC user equals and RPC password equals, right? And then that's where you would set the user and the password. And then presumably on your software, Justin, the Junction software, or is it actually in the hardware wallet where you're giving it, okay, here is my RPC username and password that I previously put into my Bitcoin Core conf file?
Great question. It is all in the this duct tape junction layer. All the sort of permission RPC username and password would be stored by this UI, and none of that will be known by the hardware wallet. The hardware wallet the hardware wallet's really stupid. Like, that's the whole idea of a hardware wallet. It just knows as little as possible. It can only see the outside world through a tiny little hole. It can only respond to very simple messages. So it doesn't know anything like that. It just says, hey, if it gets a request over a QR code, it knows how to respond to that. That's all it does. So it doesn't know anything about the blockchain. And that's the importance of this PSBT format. A PSBT will give the hardware wallet everything it needs to do its job. So the hardware wallet only needs to deal with this one format.
Gotcha. And so I guess the other question that a listener is probably thinking, well, what about this idea of building trust in the firmware and the software, right? So the idea is eyes on the code, and people say, well, Bitcoin Core has the most eyes on the code. How do we build trust in the firmware and the software needed for these projects?
I think a big thing on the UI front is that it's just very little code, actually. It's all Bitcoin Core. Like, that's the cool thing for the Junction project and the projects like it. Like Stepan's working on a similar project for his Specter wallet. And I know a couple companies, like there's going to be a number of these coming out. The cool thing is that all the work is done by Bitcoin Core, which is awesome. Like, don't do any crypto in your wallet. Like, outsource as much of that to like the Bitcoin engine, Bitcoin Core. And then for the hardware wallets, I mean, absolutely, this is going to be time will tell whether these things are actually secure over the long run, whether they get hacked a lot or whether they're whether trust builds. So it's more of an experiment on that front. But I think that's probably more acceptable in multi-sig situations where loss of one key that's different. It's subject to a very different security model. That's actually acceptable and maybe good in some cases.
Also about the firmware part, if there will be more contributors that are like people thinkers that are experimenting with this firmware, then there will be more people that look at the code. So because it's not enough just to open source your firmware, because for example, look at Ledger, they open sourced the firmware and there was still a bug that was lying there for years just because people are not building on top of that. They can read the code, but they're not using it. And what we are trying to do is actually to provide a toolbox that allow people to build on top of. So if people are building on top of the libraries and the toolbox that we have, they will find bugs easier just because it is commonly in use, like similar to Bitcoin Core and libvolley and other libraries that are popular in the community at the moment. And also why Trezor crypto library is actually also pretty good because it is used by all the clones of Trezor, for example.
So the secret to getting someone to audit your code is have people build stuff on top of it, hey?
Yes, yeah, for sure.
That's the idea. Easier said than done, I think, but we'll see.
So just help me compare this, right? So most listeners will need to compare this back against something that already exists right now. If you're going, so commercially, there's Unchained Capital. So of disclosure, they're a sponsor of the podcast, and there's also Casa who are doing this as a product that you can have. But if you were doing this on your own, users most probably they're using something like Electrum, and they're using Electrum with either Electrum Personal Server, Electrum X, or Electrum Rust Server. And so the flow there would be something like use the web wallet, plug in, or not the web wallet, the Electrum wizard, and go multi-sig, hardware wallet, blah, 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 2 of 3, whatever. What would be the main difference then in the flow of using Junction or Specter desktop versus, say, Electrum multi-sig?
Well,
go ahead.
You just run your Bitcoin Core and then hopefully just run the app that can talk to your Bitcoin Core. And just go on.
Yeah, I mean, I think that's just the way it's going to move. Like, I expect a lot of these companies, like I expect Casa and Unchained are also moving in this direction, right? Like, I'm sure Casa wants their Casa node to talk to Keymaster, right? I'm sure that's coming soon. I'm sure the same is true with Unchained. Like, I just think this is the direction it's going to go. All of these companies that really help secure one of your keys and help provide both software and customer service to like make sure you don't screw up. They're going to all move to helping you talk to your own node as well. So I think the whole group is just going to move in this direction. And yeah, that's I think that's just the way, like talking directly to nodes instead of largely this kind of Electrum. It's like Electrum is just such a good wallet that was built for a long time. It just made more sense to build like an interface layer in between than to try to build a whole new wallet going directly to Bitcoin Core 2-3 years ago when Electrum personal servers were created. But I think now we're getting to the point where you can build UIs that go directly to Bitcoin Core pretty easily.
And I think the main reason is that Bitcoin Core is really moving in that direction and making it easier to use it as a watch-only wallet. Because even at the moment, if you compare the current Bitcoin Core release, I think it is 18.1 versus the master branch, you will see the significant differences. So the master branch that is like not released yet is way faster in parsing and scanning all this watch descriptors and watch only addresses and so on. So there was a lot of work done by Bitcoin Core guys to actually add support of external signers, let's say.
Great. And I think it might also be good to get a point of view from more of a development point of view around. Okay, so there's a famous XKCD doc on this topic, and it's like there are 14 different standards for doing something, and then someone says, "Oh, I know, I'll make one standard to rule them all," and then the next panel is something like, "Oh, there are now 15 standards for doing this." Yeah. So same thing with multi-signature, right? So as I understand, there are different ways to achieve it. There are, and fundamentally, you still have to know, and this also relates to an earlier episode where Rodolfo was talking about walletsrecovery.org, right? And this idea of, well, okay, it's fine, it's all well and good for this wallet to know, but what if that wallet goes defunct, out of business, or whatever? The user still has to have the derivation path and ideally the redeem scripts, right? And so in this case, if the user is rolling their own, they still need to make sure they've got, I guess, the key pieces they would need, right? So in this case, it's probably the XPubs of those, say you're doing a 2 of 3. You would need the XPubs for those 3 wallets. You would need the redeem script as well. So can you comment a little bit on how does that kind of come together?
So the descriptors in Bitcoin Core should work as a universal description of the wallet. So ideally, you should back up only this piece of information. It includes both the XPubs and also the order of these wallets, and also the way how to construct the redeem scripts. So at the moment, Bitcoin Core supports only like single key and multi-signature descriptors, and as far as I know, they want to include mini scripts there, and then we will be able to construct very interesting wallets that, for example, include the time locks and other things like this, and they will all be displayed and configured by this descriptors language. So I think that then the only thing that you will need to store together with your wallet, like a backup, is this descriptor. So a single text file that has all the information necessary to find your Bitcoins afterwards if you screw up, if you lose your node or whatever.
Justin, did you have anything to add on that, or you mostly agreed there?
Yeah, no, I agree. I think both of these, it's like the hobbyist wallet and the sort of like new RPC multi-sig UI thing, the two sort of things we've been discussing here. I think both of them stress just like reusing whatever the standard is. So like these hobbyist wallets just use the seed, the mnemonic seed. Not trying to innovate there, just like reuse that UI, make a nice way to interact with it. So I don't think it's a problem there. And with like the kind of multi-sig wallet setup, outsource everything to Bitcoin Core. And I think it's like one less standard. All the important stuff is happening in Bitcoin Core. So yeah, I view it as the other direction, just like try to lean as much as we can on Bitcoin Core so that, you get these standard setup.
Yeah, because it is first our reference implementation, and also I would say that if there are 14 standards and then someone invents the 15th standard that goes into the BIP, then we have the standard and 14 other standards.
No, those are great points, guys. Agreed. So then from an estate planning, backup, recovery point of view, as you're saying, then it's mainly keeping the output descriptors, and obviously the private key each is held on each of the 3 different devices. So that would be the main thing you have to worry about there. So what about some of the other ideas? So things like ongoing support. Is there going to be like a chat channel for people to all support each other? What's your view there?
You mean on making this do-it-yourself hardware wallets? Okay, so that's why we decided to put online this website, DIYBitcoinHardware.com, where we hope to put also the links to the Telegram and make a Telegram group where people can actually ask and get help with assembling this, and if people don't want to go to open an issue on GitHub, for example, they can just text there. But we didn't really set it up yet. So hopefully we will do it soon after the podcast and put the link in there.
Great. And also, I guess the other one that people might have a concern about, and I suppose if they're more of a tinkerer or a builder, they're not as concerned with this, but they might be wary of using it if they think, oh, maybe this project might fall into disrepute, or it might just go stale. You know what I mean? What's the hope there? Is the hope there that it'll just be continually built on, and then once there's additional use, then it'll be seen more like a community project to keep updated?
So from our side, I can say that we are building this wallet and the desktop app to use by ourselves. So we are just building tools for ourselves, and we desperately need something like this. This is why we started all this. As far as we are in Bitcoin and we keep using it, we will continue working on it and adding new features. For me, it is especially important because I'm now part of the hardware company. So it will stop probably only if I die. Hopefully it will never happen. And even then, if we have enough contributors and we raise enough kind of interest in the community, then the progress will continue. And Justin is planning to start the course on hardware wallets with MicroPython. So hopefully there will be more and more developers that are building on top of this toolbox and starting tinkering. So I think that to make sure that the project will survive and evolve, we really need people to start working on that. And we will try our best to get more people on board.
Yeah, I would say be skeptical of us. Like if you're listening to the podcast, assume Stepan and I are over-promising and we're full of crap. And that's good. But hop in, and if you want to play around with this stuff, put some testnet coins on it. Put a little, tiny bit amount of real Bitcoin if you're reckless. But don't go and maybe redo your entire cold storage the first week that we announce it. Be a little skeptical, wait around and adopt it kind of gradually. And like you do with anything, right? You don't want to go buy a new Trezor and then just stick your entire net worth on there, the first time. You want to practice with it. And I think that's a big thing, it'd be good to see more of. It's just, or it's just a good idea just to practice with these things, explore them, use it on testnet all the time. And over time, you get more and more sophisticated, and then you can make that final decision whether it actually is secure or not yourself, because you just got to be more sophisticated. As Rudolfo explained on the previous podcast, like being your own bank is a responsibility, and you can't outsource that. You need to actually develop the sophistication yourself. And I think that's one of the big value propositions of playing around with these hobbyist hardware wallets is it helps you develop that sophistication so you can make good decisions yourself.
Fantastic. And Justin, maybe you just also want to comment on, are there any upstream dependencies or anything that has to get merged into Bitcoin Core before this is easy for noobs to use, right? So we were talking about HWI earlier, but you were also mentioning that you could just do this from an RPC point of view. Can you comment on that?
Yeah, so just with my little Junction project, there are a number of little annoying things that it'll continue. So it works now. It'll continue to improve, but one of the trickiest things is that this HWI project, which is a brilliant interface for these different vendors, sort of like a standard way to access these different vendors who behind the scenes all work very differently. There are some things that you just can't do. You can't say, hey, Trezor, show this multi-sig address on the screen. You really want that, because if you're going to read your cold storage, receive a bunch of coins on a new address, you really, really want to be sure you actually control that address. And the idea is that the hardware wallet should be like the trusted UI, right? The desktop might be malware. The hardware wallet is like the trusted UI. This is the one UI I believe. And maybe if a couple desktop machines agree, I'll sort of believe them. But I really want to have this one hardware wallet UI that I can trust. And there's no way to just say, hey, show this multi-sig address. And so that's one of the difficulties of making a standard interface layer. They haven't figured out how to make this work on all three devices. Another tricky thing is that it doesn't detect change addresses. And that's just a decision on the part of Andrew Chow. He's like, I don't see a good way to do this yet. So like any sort of standards based thing like HWI, it always lacks a little bit in functionality, right? These two are good examples. But the benefit is that you get this standard thing that everyone can plug and play with. But hopefully doing some of this hobbyist stuff like this Junction and this Junction UI, we can help sort of drive a little bit of the, give some of these Bitcoin core maintainers some feedback about what the, use cases would be helpful, and can help to sort of give some feedback and drive the development process forward there a little bit based on user input.
Excellent. Yeah, so that sounds great. Stepan, did you want to just give us a quick update? What's happening? What's the latest with Crypto Advance?
Yeah, so we decided to actually publish the code of our, let's say, functional prototype. That is why we are also releasing this do-it-yourself hardware wallet and the desktop app that is talking to Bitcoin Core, because well, who knows what community will find useful and interesting and what not. So we decided to release it at the moment, even though it is not a perfectly secure, like it is not secure at all because it is a functional prototype. This means that it can sign, it can display things, it can add new cosigners and display multi-signature addresses and things like that. But it didn't go through the security audit yet. It is like a little bit of spaghetti code everywhere and so on. But at least this is something that already lets people to feel the interface and capabilities of the wallet that potentially can be made. And also we are using the same prototype to experiment with new features like CoinJoin, Lightning Network, and other additions to the protocol. And yeah, we also want to give a tool for other developers to try it out and to see how we can improve and how the software parts of the, or let's say, Bitcoin Core or Electrum or other wallets can improve. So that is the current status. So we decided to focus on this do-it-yourself approach for now, and get the community feedback, and then from there continue working on both the consumer hardware wallet like a Series 1 and enterprise solution and other things like in parallel with that. So we hope to get some feedback from this do-it-yourself project to align ourselves for the future. So a little bit selfish, but hopefully community will also get something from it.
Yeah, I think they will. Justin, do you want to just give us a quick update what you're doing with BUIDL Bootcamp and some of your projects?
Yeah, so I've been teaching BUIDL Bootcamp for like 10 months now. So one of the things we do is we build a couple hardware wallets, build some software wallets. So if you're interested in that, please join. It's a good group. And I made like a Mooniversity class, it was called. It's like a learn to code class where everything's about Bitcoin. So if like you're interested in coding, you can check that out. Interested in learning to code. So it's the idea is like leverage people's interest in Bitcoin to help them learn to program, because that's a very useful skill. And the idea is eventually I'd turn that into kind of like a subscription, more subscription site where it's just like a kind of all kinds of little examples of stuff you could do Bitcoin programming wise. If you want to learn how addresses work, if you want to learn to build a block explorer, there's all these little projects that you do. So I'm sort of like slowly rolling that out. And yeah, I want to do a Lightning class here pretty soon too. I've been sort of putting that together, talking to some companies, and hopefully that'll happen.
Fantastic. So look, let's just talk about where, if the listeners now they want to find out more about Junction or about Specter Desktop and about this project, where should they go to find the info?
So let me just get this, DIYBitcoinHardware.com. That'll sort of have everything from these. If you want to see the Crypto Advance stuff, go to github.com/CryptoAdvance. They have the two projects just recently posted. So check those out, like really impressive looking. And yeah, Junction is just github.com, Justin Moon /Junction. But that'll probably be on the, yeah, you can find that. So yeah, I think most of it is just on that Bitcoin, DIYBitcoinHardwareWallet.com. We'll try to put all that stuff there. So if you want to dive down the rabbit hole of playing with Bitcoin hardware, learning how private keys work, and sort of like tinkering, that's where you can find Stepan and I.
We'll put all the links in the show notes for the listeners. You guys can go and click around and have a read on the material there. So look, thank you very much again, Justin and Stepan, for joining me today.
Thanks for having us. It was a lot of fun again.
Yeah, my pleasure. It's I just have to mention that we have a person in Texas, we have a person in Australia, and a person in Moscow. So one of us is very tired right now in the middle of the night. We'll let the listener guess who that was. It's crazy, though. It's crazy how this works.
Thanks, guys.
Yeah, take it easy.
So, if you're interested to get reckless and learn and play around with DIY hardware and multisig, make sure you check out the links in the show notes. That brings the Hardware Wallet series to a close. I hope you got a lot of value out of this and that this becomes a nice resource to refer people to. So some notes for a newbie listener, just summing things up. So if you've gotten through this whole series, congratulations, this is some pretty technical material. If you're still stuck leaving your coins on the Bitcoin exchange, I highly recommend you to get a hardware wallet and get off the exchange, right? So if you're stuck in quote-unquote analysis paralysis and don't know which hardware wallet to go with, I will just pick one. I'll recommend the cold card. Go to coinkite.com and use the code Livera to get 5% off. I truly believe it's the best overall blend at the time of recording this in late August 2019. Having the potential for a completely air-gapped setup and SD card air-gapping for PSBT transactions are some great features. Now, if you're more of an intermediate or advanced listener, make sure you consider the different products mentioned as part of this series and use that to inform your decision and your knowledge in how you guide your newbie friends. So one tip that I've found is don't expect people to go from 0 to 100. Try to give them just the next incremental step, the next progressive step of, okay, you're on the exchange, get a hardware wallet. Okay, you've got a hardware wallet, learn to run a node, that kind of thing. I found that to be helpful. Just remember, show notes and transcripts are on my website, stephanlivera.com. If you like the show, make sure you tell your friends and family about it. There is also a Patreon for donations. I've also recently set up a BTC Pay server on my website for Bitcoin donations. That's BESH32 only. And I'm also looking into Libra Patreon as well. But just having a bit of trouble with the email server config. But anyway, I'll get around to that. That's it from me, guys. Thank you for listening, and as always, I will see you in the Citadels.